Hi everyone. Let's continue now with problem number 3. So I have a double box plot and it shows the number of points scored by the football team for 2 seasons. And what I want to do is compare the centers and variations of the 2 populations and then answer the question, during which season was the team's performance more consistent? Well, this is a box and whisker plot, and because it's a box and whisker plot, the center that I have to use is a median. So let's look at last season's median and this season's median. So last season, the team scored 20. The median is 20. And this season. So it looks like the data is the same, that the team scored 20 points during both seasons. But now let's take a look at the shape. Notice that last season, I have, first of all, I got an outlier way out there. And if I folded right along here, this would not match. So I've got a wide space in there, got another wide space there. So I'm going to say that this data is skewed. And then let's take a look at this season. Now look at this season. This season, between each of my quartiles, I have 5, 10, 15, 20, 25, 30. So that data is symmetric. Now, when I go to figure out my interquartile range for last season, I'm going to take 25 and I'm going to subtract 10. This 25 is my upper quartile, my lower quartile. So this interquartile range is 15. And then on this season, my IQR is going to be 25 minus 15, which is 10. So now as I look at these 3 parts of the graph, notice that the team's performance, even though if I only looked at median, it looks like it was the same for last season and this season. If I look at the shape and I look at the interquartile range, I'm going to see that this season they were much more consistent. I have a smaller interquartile range and my graph is symmetric. So my conclusion is this season the team was more consistent. More consistent. All right, let's take a look at this last one. Again, the last one is the dot plot, so we're going to look at the mean. And again, I've got, actually, if we look right at the graphs themselves, you're going to see that I have nice symmetry on both. If I go to the middle of the house cats, I've got 2, 1, 2, 1. If I go to the middle of the small dogs, again, it's the same on both sides. So we are going to use mean for both house cats and small dogs. So cats, dogs. And just by looking at the graph, I can tell that both of them have symmetry. They're both symmetric. So I'm going to just put that down right now. Now, remember, anytime you have a dot plot, you have to go through and make sure that you add 9 plus 10 plus 10 plus 11 plus 11 plus 11 plus 12 plus 12 plus 13. All right, so I'm going to just write that out, but then when I go and add up all those numbers, I am going to get 99. There were 9 house cats, so I'm going to divide that by 9, and I'm going to see that my mean is going to be 11 pounds. So here again, I have to add 9. There are 2 10s. There are 3 11s. There are 2 12s. And then a 13. And as I said, when I add those all together, I'm going to get 99. I'm going to divide that by 9, and my mean is 11. I'm going to do exactly the same thing with small dogs. It's just that this time with small dogs, there are actually 11 numbers here. So remember, you have to add all 11. So I have a 6 plus 7. And there are 2 8s. There are 3 9s. 2 10s. and 11 and a 12. And when I add all of those together, I get 99. But this time, because I have 11 dogs, I'm going to divide it by 11, and my small dogs, my mean weight is 9. Okay. Now, again, remember with mean is associated with mean absolute deviation. So now I have to go back and I have to subtract 11 and 9 and 10 and 10 and 12 and 12 and 13. Add those all up and divide by 9. So I'm going to just give you what those MADs would be. So on house cats, there's a difference of 2, and then 1, 2, 3, 4, and then 2. And remember, I'm getting that by taking 11 minus 9, 11 minus 10, 11 minus 10, 12 minus 11, 12 minus 11. So that's going to give me 8, and I'm going to divide 8 by 9 so that the MAD is 8/9 or 0.8 repeating. And that's a really good MAD because that tells me that my data is really close together and consistent. So now let's take a look at the small dogs, and we've got a 3, a 2, and then 1, 2, it looks like 4 ones, 3, 4, and then another 2 and another 3. And when I add those all together, I'm going to get 14, only this time I'm going to divide 14 by 11. And when I divide 14 by 11, I'm going to get 1.27. And again, 1.27 is not a bad MAD. It's a smaller number, which tells me that my data is pretty consistent. So the closer my numbers are to the mean, the more consistent that my data is. So again, we could begin looking at this and begin to make some predictions about it. Our data is good. The data is consistent with both dogs and cats. So it looks like that cats have an overall higher weight average than small dogs, but otherwise everything else on that data looks good. All right, make sure that you fill in the Google form, and if you have any questions, we will talk about them tomorrow.